Hi, my name is Bloodfish and welcome to the third circuit video. In this video I'll be focusing on the monostable circuit, so let's crack on. First things first, what is a monostable circuit? The basic function of a monostable circuit is to create a one-tick pulse, no matter whatever pulse is being put into it. So for example, this is your basic monostable circuit design, and like this is just a 5-tick pulse button, so even if I press this button, a 1-tick pulse is generated. And when this 1-tick pulse powers a piston, a sticky piston, this sticky piston will spit out its block instead of just like pushing and pulling, like what a sticky piston is supposed to do. This is because like the pulse is so short, so like the sticky piston just spits out its block. So how does this work? I'll just make it clear for you guys to see. When I press this button, this repeater will be powered, and then this repeater will power two components. This repeater and also this piston, which will act like a circuit breaker. And also these two components have a 1-tick delay. So after 1 tick of delay, this repeater will be on and this piston will be extended, and so the block will be here. But after that 1 tick of delay, this repeater will realize that it's not being powered because there's no block to get an output from because the block is up here, so it turns off. And in that brief moment that this repeater is turned on, that's when a 1-tick pulse is created. But here's something to mention, is that if you want to make one of these monostable circuits, you cannot have a 1-tick pulse as your input. This is because like, if you do so, then like you will make it so that every 2 times you activate the circuit, you will only get 1 output from it. So like this, if I just activate once, then twice, 1 output. First time, second time, 1 output. So it's not recommended for you to do this. How do you build this circuit? It's rather simple. You just need like the following items and blocks. So just like break a block in the middle, put a piston over here, sticky piston, sandstone, and then like just like 2 repeaters like that, and just have to like have an input over here, and yeah, that's your basic monostable circuit. Since the monostable circuit doesn't really have any applications in survival, I'll just talk about the different uses of the monostable circuit. So in this first example, if you're using a monostable circuit, you're basically talking about how to manipulate a 1-tick pulse. And as you can see, this 1-tick pulse can be used to activate many different circuits. For example, a pulse lengthener, a clock, and it can be lengthened to different delays, so like 4-tick, 3-tick, 2-tick, and 1-tick. And this can also mimic the actions of a lever, so it can create a constant output over here. So if I just flick this button, you can see all of these circuits have been activated, and even this lever. So basically, if a button can act as a lever, you basically don't need anything else as your activation device. You just need a monostable circuit. And then for a second example, we have a monostable circuit acting as a double piston extender. So how this works is just that the observer powers the piston at different positions like that. So the piston will be able to retract and like extend the block accordingly. And for a further example, I've mentioned this before, but the monostable circuit can be used like a safe lock so that these 2 pistons will not be able to interfere with each other. So basically, if I just press this button, this piston will activate and then deactivate before this piston activates and deactivates, just like this. For our fourth example, we can see the interactions between a monostable circuit with an observer compared to a constant pulse length with an observer. So first of all, we know that the monostable circuit has a really short pulse length, and so therefore, because it's so short, the observer will only be able to detect the change once, just like this. Only once when it's activated. However, if we were to change its interaction so that the observer will fire twice, we can change this pulse length to a pulse length of 3, and because like the 1-tick pulse is so flexible, it will be able to cope with this. And so now when like the pulse length in front of the observer is higher than a pulse length of 3, or 3 of course, then like the observer will be able to activate twice in the same activation like that twice. And then we compare these two. So if we have a constant pulse length, something like this component will activate according to the lever. So like this, if it's activated, then like this component's on, and like when the lever's deactivated, the component turns off, just like that. However, if it's a monostable circuit, then like this only activates when it's rising, or like we should say the rising edge of this lever. So like when it's activating, like when it's activating, it activates twice, but when we deactivate it, it doesn't happen because like we already activated and deactivated it twice, just like that, rising edge, falling edge. And then for our next example, we can see these 3 components, just like assume they're 3 components, and we want it so that this piston will spit out its block, this piston to push and pull, and this piston to spit out its block. So if we were to just run this circuit, we can see that this is attached to a monostable circuit, so this will spit out its block, and then this is attached to a longer pulse, so it doesn't spit out its block. But then if we were to continue this pulse, it will just power this piston, and this piston would like push and pull its block. So what do? We want to reset the pulse. And how do we do it? We use a monostable circuit. So like this will reset any length of a pulse here, so like 4-tick pulse, it will reset it back to a 1-tick pulse over here, so therefore this piston will be able to spit out its block, just like this. Spit, push, pull, spit, like that, it resets it. So like even if you like use a pulse lengthener, like those clocks I showed you over here, you can still reset it back to a 1-tick pulse using a monostable circuit. And then we move on to the final example, which is why we use a sticky piston and a monostable circuit. So if we were to compare these two pistons, sticky piston and normal piston, like the main reason we want to use a monostable circuit with them is because we want to have like the properties of a sticky piston and also a normal piston. So like this, you can see that both pistons are able to spit out their blocks like that. However, only the sticky piston is able to retract the block like that, and the piston is not able to do so because it's sticky, and that's why we use a monostable circuit. It's because we want a piston that can like freely retract or extend the block as we want it to, like that. So yeah, different uses of this monostable circuit. And finally, here are different variations of the monostable circuit. Now just now I mentioned something called rising edge and falling edge, and what it is, it's basically a process that follows when the activation device is turning on or turning off. So if I just take this button for example, so when I press on this button, it's rising edge. When it like deactivates, it's falling edge. So this is a falling edge monostable. It activates when the button is deactivating, like that. When it deactivates, there's an output from this piston. How it works, it's just basically like the first one. It's just like, yeah, circuit breaker and all that. It just like replaces the redstone dust here with a redstone torch. And then we have another example of this over here. This is just another example of a falling edge monostable circuit, and it utilizes the locking repeater feature. So how does it work? If we think about this logically, so 1 tick of delay after this button deactivates, these 2 repeaters are still on, and this repeater is being locked by this one. By the next tick of delay, these 2 repeaters are off, and since this repeater knows it's like the next tick of delay, this should be on. And since like this repeater is off, this repeater has no locking delay, so therefore there's going to be an output from this repeater, and so therefore this piston activates just like that. Yeah. And then for our third example, we can see that this piston, it's like a circuit breaker. So it breaks the circuit between like this repeater and also this piston. And one thing surprising is that like this activates twice. It's like this is a dual edge monostable circuit. Activates both on rising edge and falling edge of this button. That's like terminology, dual edge. Anyways, how does it work? So this utilizes the feature of how a piston, when it retracts, it has a 0, like there's no delay when it retracts. So like when I activate it, repeater, and then when it deactivates, this piston deactivates immediately, so there's still gonna be some pulse left in this repeater because it's still like that same tick of delay, so it just continues that 1 tick of pulse, dual edge, monostable circuit. And then we go on to the most commonly used one, the one I've been using for the video. This is an observer monostable circuit, and just like activates when I move it. That's it. When an observer moves, it activates. And this is useful because you can orientate this like in many directions, so that you can put it sideways like this, top, sideways again. Yeah, maybe not like when it's facing down because that just doesn't power anything. Yeah. And then if we were to combine this dual edge monostable with a normal monostable using this observer monostable, we get this. So we want to power this piston twice and this piston once. So we just like have this observer like powering this piece of redstone dust twice, indirectly by powering this block first, and then directly by powering this piece of redstone dust. So like this powers the block once, twice, because like this block is powering this dust, so like yeah, it just activates twice. So this piston activates twice and this just activates once. And yeah, different uses of variations of this monostable circuit. And so at the end of the monostable circuit video. So like this video, the monostable circuit didn't really have any applications in survival, so it wasn't very interesting. It was mostly theory about how to use this monostable circuit, but I still hope that you found it useful. And so yeah, I'll see you next time. Goodbye.